Hey friends, it's Mr. Patrick here from the Pleasant Hill Library with another project from your 2023 Tinker Kit. This one is going to be maybe the hardest project in the whole kit. Let me tell you about it. Well, you've made a tambourine and you've made a drum machine, so it might be hopping at your house right now. But we're going to keep the party rolling with a disco ball. Now, the disco ball is going to utilize your ball, all right, yours might be a different color than mine, and this sheet of mirrored mylar, all right? And you can imagine this is going to go on top of this. It's a little harder than it might seem. Wrapping a two-dimensional object around a three-dimensional shape, it's puzzled mathematicians for a really long time, and I'm going to share a link below to tell you really how complicated that math problem is. But let's start with a really simple math problem, which is, do we have enough of this to cover this? Let's do it. All right, let's do a little math here and see, do I have enough mylar to cover my ball? Well, I need to compare the area of my mirror to the area of my ball. So, a little math here. The area of a square is going to be equal to one side multiplied by the other side. In this case, they're the same number. So my square is 6 inches times 6 inches. That's going to equal 36 inches. All right, squared. So, let's see here. Do I have enough to cover this guy? Okay, now let's see if we can figure out the surface area of this ball. I happen to know that it's 2.5 inches wide, okay? Let's see here. So that means the diameter is equal to 2.5 inches. And that also means that the radius is going to be half of that, 1.25 inches. All right, let's take the formula for the area of the surface area of my sphere, and that is going to be 4 pi r squared. All right, I know that's kind of some scary math there. Let's see if we can break it down to something a little bit easier. Another way to write that would be 4 times 3.14, which is a close approximation for what that pi means, times the radius, 1.25, times the radius again, 1.25. All right, if I punch that into my calculator, I get 19.625 inches. Now, when I compare that to this, I can see I should have plenty of mylar to cover my sphere, but it gets a little tricky. All right, now we've done some tricky math to know that we have enough mylar to cover our ball, but it's going to be trickier still to really encase that ball. And this is, again, a problem that mathematicians have been puzzling over for a long time. It's kind of the reverse problem that cartographers or map makers have been wrestling with for a really long time. Have you ever looked into a picture of an atlas, trying to picture the whole globe, which is a sphere, on a flat page for you to look at? It always seems kind of strange, right? Why is Antarctica so huge, right? It's the same problem these map makers had when they tried to unwrap the sphere of the sky onto this page, right? You get some pretty funky shapes. So we're going to struggle with that today in trying to get this square, flat piece of mirror onto a round surface. And you've got a few different ways that you can do it, all right? There's going to be an easy way and a hard way, and then there's a whole third way. All right. Now, the first way that's actually pretty easy is by cutting your mirror apart into teeny little pieces and then using some hot glue, if you've got a hot glue gun around, to stick each of those teeny pieces on your sphere. Cutting it up into lots of little pieces makes the job easy because there's no folds and crinkling and frustration there. Now, it has its own challenges because a hot glue gun can melt your plastic ball. And it can also be a little sticky and scorchy on the fingers, so watch out if you choose to go that way. You may want to get a little help from a grown-up. Now, the second way is a lot more challenging and involves folds, all right? And the way you're going to do that is folding your Mylar up into a shape that can contain your ball. All right. Now, it might not be perfectly spherical. There's really no way to do that with just scissors and some sticker. But we can get pretty close to create a disco ball that shines. And now the third way that you can go, if you find those first two options a little too challenging, is to simply explode the idea of a disco ball and go with a completely different shape altogether. All right, here's a few different ideas for you. You might go with just some crazy geometric origami version. You might go with this one. I think of this as like a disco jellyfish. All right, fill in the blank and try a completely different shape. I guarantee you with this mirrored Mylar, you're gonna get lots of reflective surfaces to bounce that light around your room, right? So you've got three options, or you've got other options that you can explore. Maybe you have a better option that I haven't thought of, all right? It's definitely a tough geometric puzzle, but I think you're up to the challenge. Well, have fun in trying to wrap your Mylar around the ball. Now that we've got the disco ball itself, we want to hang it up from the ceiling. So I'm gonna unbend a paper clip and poke a hole with the needle through my disco ball and feed a wire through. If you want it to hang a little bit lower, you could use the wire in your kit or find a larger paper clip around the house, but you're definitely gonna need to thread a metal strand through your disco ball. All right, we've got it spinning. Now let's motorize this disco ball. There's a couple different ways to do it, but you're gonna need your motor for all of these. You can, if you've used the hot glue method, simply glue it into this little hole right there, right? Doop. Or we can do this. Take one of the legs from your Robo-Chariot and a rubber band, and you've done this before, right? Getting traction on the legs of your robot. Just do this a few times, all the way down the leg. Bend your wire all the way over and tuck it into these, right? Such that your the center of your disco ball is over this. And put this guy back in here. And perfect. Okay. This is spinning way too fast with the AA battery pack. Let's use this coin cell battery pack instead. Just pop it right in there. Make sure that the plus side is up. Yeah, and I've got a little switch on the side to turn it on and off. Let's wire up the motor with this instead. And the AA I can use for this super bright LED. Very nice. There's a short leg and a long leg to this LED, so make sure your short one's attached to the black wire, long one to the red, and just twist it up. You could use a little tape to secure it in place. And now, yeah, switch it on, we're ready to party. And disco. Cue up a little Donna Summer, put on your dancing shoes. I'll see you in the next video, Tinkers.